Download this code from codegive.com, link in the description below. Boundary value analysis and boundary value coverage in software testing, a comprehensive tutorial. Boundary value analysis, BVA, is a black box software testing technique used to test boundary conditions in software applications. It's based on the idea that errors often occur at the boundaries of input domains. Boundary value coverage is a test design technique within BVA that aims to systematically cover these critical boundary values to find defects. It is a crucial part of a robust testing strategy. This tutorial will delve into the following aspects. 1. What is boundary value analysis? 2. The rationale behind boundary value analysis. 3. Boundary value coverage test design technique. 4. Identifying boundary values. 5. Advantages and disadvantages of boundary value analysis. 6. When to use boundary value analysis. 7. Code examples, Python, Java, C++. 8. Improving boundary value analysis with robustness testing. 9. Common mistakes to avoid. 10. Integration with other testing techniques. 11. Real-world example and case study. 12. Tools and automation. 13. Conclusion. 1. What is boundary value analysis? Boundary value analysis, BVA, is a black box testing technique where test cases are designed using the boundaries of the input domain. Instead of testing random values within the domain, BVA focuses on the edge cases, the maximum, minimum, and values just inside and outside of these boundaries. For example, if an input field accepts values between 1 and 100, inclusive, BVA would focus on testing values like 0, 1, 2, 99, 100, and 101. 2. The rationale behind boundary value analysis. The core idea behind BVA is that software errors tend to cluster around the edges of input ranges. This is often due to off by 1 errors programmers might use instead of equals or vice versa in conditional statements. Incorrect data type handling a variable might be defined with insufficient capacity to store the boundary value, leading to overflow or underflow. Flawed logic boundary conditions are often handled separately with special cases. If the logic for these cases is not implemented correctly, errors can occur. Assumptions about input validity. Developers might assume that users will always input valid data, leading to insufficient validation for boundary conditions. By testing these boundary values, we have a higher chance of uncovering defects that might otherwise remain hidden until the software is deployed. 3. Boundary value coverage test design technique. Boundary value coverage is a specific test design technique that dictates how to select the test values for BVA. The goal is to ensure that all boundaries are adequately covered. For a single input variable, the typical boundary values selected are min the minimum allowed value, min plus 1 a value slightly above the minimum, nominal / typical a valid value within the range, often the midpoint, max, 1 a value slightly below the maximum, max the maximum allowed value. If there are multiple input variables, each variable will be tested with its own set of boundary values. However, to reduce the number of test cases, it's common to apply a one variable at a time approach. This means 1 for each input variable, test its boundary values, min plus 1, nominal, max, 1, max, while keeping other variables at their nominal / typical values. 2. Consider additional boundary values outside the expected range to test for robustness. Min -1, max +1. This is often called robust boundary value analysis. Example asterisk. Let's say we have a function calculate_discount that takes two integer inputs. Asterisk age, acceptable values are between 18 and 65, inclusive. Asterisk purchase_amount, acceptable values are between 10 and 1000, inclusive. Using boundary value coverage, we would generate the following test cases. Test case age purchase_amount expected output, example. Dash 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 dash. 117,500 error/invalid input. 218,500 discounted price. 319,500 discounted price. 464,500 discounted price. 565,500 discounted price. 666,500 error/invalid input. 749 error/invalid input. 840.10 discounted price. 940.11 discounted price. 1040,999 discounted price. 1140,1000 discounted price. 1240,1001 error/invalid input. Notice how each variable, age and purchase_amount, is tested with its boundary values, min1, min plus 1, max 1, max plus 1, while the other variable is kept at a nominal value. 4. Identifying boundary values. Identifying boundary values accurately is critical for effective BVA. Here's a breakdown of how to approach it. Asterisk review requirements. Asterisk carefully examine the software requirements specification, SRS, functional specifications, or user stories to understand the valid input ranges for each input field. Pay close attention to phrases like between X and Y, inclusive, greater than X, less than or equal to Y. Asterisk data types. Asterisk consider the data types of the input fields. Integer, floating point, string, date, and Boolean types all have different boundary characteristics. Asterisk equivalence partitioning. Asterisk combine BVA with equivalence partitioning. First, identify equivalence classes, sets of input values that are likely to be treated the same by the software. Then, apply BVA at the boundaries of each equivalence class. Asterisk output boundaries. Asterisk don't just focus on input boundaries. Also, identify the boundaries of output values. For example, if a function calculates a percentage discount, consider testing cases that might result in a 0% or 100% discount. Asterisk constraints. Asterisk look for constraints imposed on the input values. For example, a field might be required to be a positive number or to match a specific pattern. Asterisk contextual factors. Asterisk consider the context in which the input values are used. A value might be valid in one context but invalid in another. Example asterisk. Suppose a system manages employee information. Here are some examples of identifying boundary values. Asterisk employee ID. Asterisk must be a positive integer between 1000 and 9999, inclusive. Boundary values, 999, 1000, 1001, 9998, 9999, 10,000. Asterisk salary. Asterisk must be a non-negative floating point number less than 200,000. Boundary values, -0.01, 0.00, 0.01, 100, and 99,999.99, 200,000.00, 200,000.01. Asterisk date of birth. Asterisk must be a valid date between January 1, 1900, and the current date. Boundary values, dates around January 1, 1900, dates around the current date, yesterday, today, tomorrow. Asterisk gender asterisk must be either male or female. Boundary values, male, male, female, female, misspellings should be tested. 5. Advantages and disadvantages of boundary value analysis. Advantages asterisk. Asterisk effective at finding errors asterisk BVA is known to be very effective at finding a large number of defects, especially those related to off-by-one errors or incorrect input validation. Asterisk easy to understand and implement asterisk the technique is relatively simple to learn and apply, making it accessible to testers with varying levels of experience. Asterisk reduces the number of test cases asterisk compared to exhaustive testing. BVA significantly reduces the number of test cases needed while still providing good coverage. Asterisk complements other testing techniques asterisk BVA can be effectively combined with other black box techniques like equivalence partitioning. Disadvantages asterisk. Asterisk limited applicability to complex logic asterisk BVA is primarily focused on input boundaries and may not be as effective at finding errors in complex algorithms or internal logic. Asterisk may not detect all boundary-related errors asterisk if the error lies in the combination of several boundary conditions, BVA alone may not detect it. Asterisk requires clear specifications asterisk BVA relies on clearly defined input ranges. If the specifications are ambiguous or incomplete, it can be difficult to identify the correct boundary values. Asterisk assumes independence of variables asterisk the one variable at a time approach assumes that the input variables are relatively independent. If there are strong dependencies between variables, this approach may not be adequate. 6. When to use boundary value analysis. BVA is particularly well suited for the following situations. Asterisk applications with numeric or date input fields asterisk BVA is most effective when dealing with input fields that have defined ranges or boundaries. Asterisk systems that process data based on specific criteria asterisk if the system makes decisions based on comparisons to boundary values, BVA is highly relevant. Asterisk areas where input validation is critical asterisk when it's important to ensure that the system handles invalid input gracefully, BVA can help uncover vulnerabilities. Asterisk integration testing asterisk BVA can be applied to test the interfaces between different components or modules, ensuring that data is passed correctly across boundaries. Asterisk regression testing asterisk BVA can be used to verify that changes to the code have not introduced new errors related to boundary conditions. 7. Code examples, Python, Java, C++. Let's illustrate BVA with code examples. We'll use a simplified function calculate_discount that calculates a discount based on age and purchase amount, as described earlier. We'll create test cases based on boundary value coverage. Python asterisk. Java asterisk. C++ asterisk. Key points in the code examples asterisk. Asterisk clear boundaries asterisk the functions explicitly define the valid ranges for age and purchase amount. Asterisk error handling asterisk invalid input is handled by returning a specific value, example -1 in Java/C++, invalid input in Python. Asterisk test cases asterisk the test cases cover the boundary values, min1, min, min+1, max1, max, max plus 1, for both input variables, while keeping the other variable at a typical value. Asterisk assertions asterisk the tests use assertions, unitest in Python, assert in C++, to verify that the actual output matches the expected output. Java uses simple system.out.println for demonstration. JUnit is the preferred testing framework. 8. Improving boundary value analysis with robustness testing. While BVA focuses on values within and immediately around the valid range, robustness testing extends BVA by also including extreme out-of-range values. This helps to identify how the software handles unexpected or erroneous input. Robust boundary value analysis test values **** min, 1 ** a value slightly below the minimum allowed value. ** min ** the minimum allowed value. ** min plus 1 ** a value slightly above the minimum. * nominal ** a valid value within the range. * max, 1 ** a value slightly below the maximum. * max ** the maximum allowed value. * max plus 1 ** a value slightly above the maximum allowed value. * invalid data type, optional instead of valid data types, test with invalid data types. For example, use a string when expecting an integer. Example, extending the previous example. Suppose age has a valid range of 18 to 65. Robust BVA would include the following test values. *17, *18, *19, *40, nominal, *64, *65, *66, *20, invalid data type test. By incorporating robustness testing into BVA, you can identify potential crashes, exceptions, or unexpected behavior caused by invalid input. It makes your testing more comprehensive. 9. Common mistakes to avoid. Not identifying all relevant boundaries. Missing a boundary condition can lead to undetected errors. Review the requirements carefully and consider all possible scenarios. Applying BVA blindly without understanding the logic. Don't just focus on the boundary values. Understand how the software uses those values in its calculations and decision-making. Testing only the happy path. Remember to test both valid and invalid input to ensure that the system handles errors gracefully. Failing to document test cases properly. Document your test cases clearly, including the input values, expected output, and actual output. This helps with traceability and debugging. Ignoring dependencies between variables. If there are strong dependencies between input variables, the one variable at a time approach may not be sufficient. Consider testing combinations of boundary values for dependent variables. Neglecting output boundaries. Always consider boundaries on the output side as well. Using only BVA and not other techniques. BVA is a powerful technique, but it is not a silver bullet. Use it in combination with other testing techniques like equivalence partitioning, decision table testing, and state transition testing for comprehensive coverage. Lack of automation. Manual execution of boundary value tests can be time-consuming and error-prone. Automate these tests for better efficiency and repeatability, especially during regression testing. Incorrect implementation of the test cases. Double-check that the test cases are implemented correctly. The test inputs must be truly testing the identified boundary values and the validation or the function under test. 10. Integration with other testing techniques. BVA is most effective when combined with other testing techniques. Here's how it can be integrated with some common approaches. Equivalence partitioning, EP divides the input domain into equivalence classes, groups of values that are likely to be treated the same. BVA can then be applied to the boundaries of each equivalence class to achieve more targeted coverage. First, apply EP to identify equivalence classes. Then, apply BVA at the boundaries of those classes. Decision table testing. Decision tables are used to test complex logic with multiple conditions and actions. BVA can be used to identify the boundary values for the conditions in the decision table. State transition testing. State transition testing focuses on testing the transitions between different states of the system. BVA can be used to test the input values that trigger these transitions. Error guessing. Error guessing involves anticipating potential errors based on experience and intuition. BVA can be used to formalize and systematize this process by focusing on boundary values where errors are more likely to occur. Use case testing. Use case testing focuses on testing the system from the user's perspective. When creating use case scenarios, consider using BVA to select boundary values for the input fields used in those scenarios. Pairwise testing. Pairwise testing aims to cover all possible pairs of input values. BVA can be used to identify the boundary values for each input, and then pairwise testing can be applied to these boundary values to create test cases. 11. Real-world example and case study. Scenario *. Consider an e-commerce website that allows users to order products. Let's focus on the quantity field for adding items to the cart. Requirements *. The quantity field must be an integer. The quantity must be at least 1. The quantity cannot exceed the available stock. Let's assume the maximum stock for a specific product is 100. Boundary value analysis *. Variable quantity. Minimum 1. Maximum 100. Test cases Test case quantity available stock expected result. 1050 error message, quantity must be at least 1. 150 item added to cart. 250 item added to cart. 100 item added to cart. 100 item added to cart. 100 error message, quantity exceeds available stock. 7-150 error message, quantity must be at least 1. 8 ABC 50 error message, invalid quantity format. Must be an integer. 950-49 error message, quantity exceeds available stock. 1050-50 item added to cart. 1150-51 item added to cart. Explanation *. Test cases 1 to 6 cover the standard boundary values, min 1, min plus 1, max 1, max plus 1. Test case 7 tests a negative quantity. Test case 8 tests an invalid data type, string. Test cases 9 to 11 shows that the error may appear when the available stock changes, thus requiring a separate set of BVA on the available _stock variable. Case study *. In one real-world case, a software company was developing a financial application that calculated loan interest rates. The requirements stated that the interest rate should be between 0.5% and 15%, inclusive. Using BVA, the testing team identified a critical defect. When the interest rate was set to 0.5%, the application incorrectly calculated the monthly payment, resulting in a slightly lower payment than it should have been. This error was due to a rounding issue in the calculation logic. When the interest rate was set to 15%, the application resulted in an overflow, causing the application to display incorrect results and even crash sometimes. This issue was caught by the test case using exactly 15% and was later resolved by properly handling the edge case. Without BVA, this defect might have gone unnoticed until the application was deployed, potentially leading to significant financial losses for the company and its customers. 12. Tools and automation. Several tools can assist with BVA, particularly for automation and test management. Test management tools, TestRail, Zephyr, X-Ray. These tools allow you to create, organize, and execute test cases. You can define the input parameters, expected results, and track the execution status of each test case. Some tools have built-in features to generate test cases based on BVA. Test automation frameworks, Selenium, JUnit, TestNG, ptest. These frameworks allow you to automate the execution of test cases. You can write scripts to input the boundary values, interact with the application, and verify the output. Excel/spreadsheet software. Simple spreadsheets can be used to create a test matrix and document test cases. Formulas can assist in generating boundary values. Custom scripting. You can write custom scripts, using languages like Python, Java, or JavaScript, to generate test data and automate the execution of BVA tests. This is particularly useful when testing APIs or back-end components. Model-based testing tools. Model-based testing tools create test cases based on a model of the system. These tools can generate boundary value test cases automatically. These models are usually described in a modeling language such as UML or SYSML. Benefits of automation. Increased efficiency. Automation saves time and effort by automating repetitive tasks. Improved accuracy. Automation reduces the risk of human error. Better coverage. Automation makes it easier to cover all boundary values and combinations of values. Regression testing. Automated BVA tests can be easily rerun after each code change to ensure that no new boundary-related errors have been introduced. Continuous integration / continuous delivery, CI/CD. Automating BVA tests can be integrated into the CI/CD pipeline to ensure that boundary conditions are tested automatically with each build. 13. Conclusion. Boundary value analysis, BVA, and boundary value coverage are powerful and cost-effective testing techniques that can significantly improve the quality and reliability of software applications. By focusing on the boundaries of input domains, BVA helps uncover errors that might otherwise remain hidden until the software is deployed. Combining BVA with other testing techniques, using appropriate tools and automation, and avoiding common mistakes can maximize its effectiveness and ensure that your software meets the required quality standards. Remember to identify boundaries carefully, create clear test cases, test for both valid and invalid inputs, and continuously refine your BVA approach based on the specific characteristics of your application. By following the principles outlined in this comprehensive tutorial, you can leverage the power of BVA to deliver robust and reliable software to your users.